This video is going to be about all of the circle constructions. So the first construction that we have here is to construct a circle given a specific line segment as the radius. So what I'm going to do is I'm just going to take my compass and I'm going to put it on one of the endpoints of the line segment, and I'm going to open up as best as possible to the other endpoint. And once I've measured the length of the radius, I'm just going to swing a circle, a full way around circle with my compass. And there I have a circle with a specific line segment as the radius. Okay, for our next construction, what we're going to do is we're going to construct the center of the circle. Right now we have a circle, but we don't know where its center is. So we can't just say, oh, it's right here in the middle, because we don't know where the middle is. We have to construct it and actually find that middle of the circle. What I'm going to do is I'm just going to make any two chords in the circle. Remember, chords are line segments that intersect the circle at 2 points. So these would be an example of two chords. You just don't want to make the chords parallel to each other because then the construction is going to be a little bit more difficult. So I just made them facing different ways, but any two random chords, it doesn't matter how you draw them. And now what I'm going to do is I'm going to just make the perpendicular bisector of each of these two chords. And we do try to be as accurate as possible. I'm not going to get 100% accuracy because I am using the computer here, which is a lot harder for me than doing this by hand. But we're not going to get 100% accuracy, but we do try to be as accurate as possible. So for the perpendicular bisector, all I did was open up to about 3/4 of the way down the line segment. And using the same distance, I'm going to go over to the other endpoint of that chord, of that line segment, and I'm going to make the same arc. And right through there is my perpendicular bisector. Let me use a different color so we don't get confused here. So that's my first perpendicular bisector in yellow. Now I'm going to just perpendicular bisect the other chord as well. So just like before, compass on one of the endpoints of the line segment. Doesn't matter how much you open up, it should be about 3/4 of the way down. Arc above and below, that's because I want to see the top and the bottom intersection. Using the same distance, okay. Using the same distance, I'm going to make the same exact arc. And let me use a different color for my perpendicular bisector. And right through my intersection points is my perpendicular bisector. Now, where those two meet, which here would be the point right here, that would be the center of my circle. And look how it's really, really close to being right exactly in the middle of the circle. And that's what we should expect. Okay, we're going to construct the tangent to the circle at point C. So notice that OC is a radius of the circle, and we're making a tangent line to the circle. A tangent line is a line that intersects the circle at just one point, and we want it to intersect specifically at point C. And keep in mind that a radius and a tangent to the circle are perpendicular. They form right angles where they meet. What we really want to make here is a line that's perpendicular to the radius through this specific point, through point C. So that's going to be our perpendicular line through a point construction. Now, just to make it a little bit easier, I'm going to extend the radius a little bit. Let me use the same color so you can see what I'm doing. There we go. Okay, so I'm just going to extend the radius a little bit just to make the construction easier, and you'll see why in a second. The reason for that is because the first arc that we need to make, we're going to put our compass on point C because that is the point that we want our line to pass through. And we need to make an arc on point C. And the thing is, it doesn't matter how much you open, but the arc should intersect this line segment at 2 spots. So notice how I just made an arc that intersected the line segment at 2 spots. Now you wouldn't have been able to do this unless you extended the line, because otherwise you would have only gotten on this side of point C, and there would have been no intersection on this side. So you do need to make an arc that intersects at 2 spots. Once again, I made this arc with my compass point on point C. Now that I have these two intersection points, Sorry that this keeps popping up. I keep pressing the wrong button on my computer. Now all that I have to do is go over to each of these intersection points, and it doesn't matter the radius that I use. It's just whatever radius I use here to make an arc. When I go over to the other endpoint, I need to use the same radius, the same distance to make that arc as well. So I was here and here, and I used the same compass length to make these two arcs. And that's all it is. Let me use a different color for the tangent line. I'm just going to do my best to connect through point C and the points of intersection. So I'm probably going to have to move this over because I'm doing this on the computer. And here I have my tangent line to the circle at point C, through point C. So once again, it's a line that intersects the circle at just one point, and that point should just be point C. And that's our perpendicular line through a point construction. Okay, for the next one, we're going to construct the tangent to circle O from point P. And notice how point P is outside the circle. So we're making a tangent to the circle from an external point. Now, there's two possibilities. One could go from here to this side of the circle. The other possibility is it could go from point P to the other side of the circle. We don't know which tangent we need to do, so we're actually going to make both of them since there are two possibilities. What I'm going to do is I'm going to connect the center of the circle with point P, and now I'm going to get my compass out, and I'm just going to perpendicular bisect this line segment so I could get the center. The midpoint of this line segment, I should say, not the center of the circle. We already have that. I'm going to open my compass about 3/4 of the way down. The exact length, distance doesn't matter. Big arc above. Not changing the distance. Same exact arc using the same distance because it's a perpendicular bisector. And right through that intersection point, I'm going to make my perpendicular bisector. So now I have the midpoint of this line segment. And what I'm going to do now, and I'm going to use a different color so you could tell the difference between my arcs. What I'm going to do now is I'm going to take my compass and I'm going to put it on that midpoint. And I'm just going to measure from that point to the center of the circle. So I just measured from that point to the center of the circle. So using that distance I measured, I'm just going to make an arc on the circle over here. And using the same distance, I'm going to make the same arc on the circle over here. And that's where the two possible tangent lines are going to intersect the circle. So let me get a different color for the tangent lines. And I'm going to go from right here to here. And from right here to here. And due to our construction with the perpendicular bisector and measuring equal distances, we have created two tangent lines from an external point to the circle. These are two possibilities, and they're both congruent to each other. Remember, if we have two tangents to the same circle drawn from the same external point, they have to be congruent to each other. So this tangent and this tangent would be congruent to each other. Okay, next we have an inscribed hexagon. So I'm going to get my compass, and I'm going to put my compass on the center of the circle. And I'm just going to dot a point on the circle, any point. I'm just going to dot this one. There we go. And I'm just going to measure the distance from the center to this point. And I just made a line segment so you can see what I'm measuring. You don't have to. We're just measuring from the center to the point that you selected on the circle. And here's my arc to show that I measured. So now what I'm going to do without changing the distance on my compass is I'm going to go over to that point that we started with, and I'm going to use the distance that we measured to make an arc on the circle. And then I'm going to go over to where that arc intersected the circle, and I'm going to make the same arc, same distance. I'm going to do the same thing over here. I'm going to intersect the circle, same arc, same distance, and I'm going to keep moving along. Let me just tilt this more. So difficult to do constructions on the computer. And this is my last time. because notice how I end up back at my starting point. And we're not going to be 100% accurate. We do try to be as precise as possible. If you don't end up exactly at the point that you started at, it's fine, but it should be close to the point that you started at. It should be almost lining up with the point that you started at if you did this construction correctly with equally spaced arcs. So now we have 1, 2, 3, 4, 5, 6 points where the arcs meet the circle. And using my straight edge, all I'm going to do is connect all of these points together. And there I have my hexagon inscribed in circle O. Equilateral triangle is going to be exactly the same thing as the hexagon, except instead of connecting all 6 points at the end, we're going to connect only 3 of the points. But aside from that, it's going to be the same exact construction. So once again, just like before, I'm just going to pick a point on my circle, and I'm just going to measure from the center to that point. And just like before, I'm going to go over to where it to where that starting point was. Using the same distance I measured, I'm going to make an arc. And I'm going to keep moving around the circle to where each of the arcs intersects the circle, trying to be as precise as possible. It's so hard on the computer to get it in the right spot. And there we go. So now the only difference is instead of connecting all 6 of the points together, I'm going to connect every other point together. So let me dot that for you. So I can connect my starting point, this point, and that point. Every other point together. And there we have it. We have our equilateral triangle inscribed in circle O. Next up, we're going to construct a square inscribed in circle O. So what I'm going to do first is using my straight edge, I'm going to make a diameter of the circle. I just made mine vertical. Oops, that does not look right. It's got to go through the center. It's so hard on the computer. I'm going to move it over because I want it to go right through the center. I want it to be a diameter. And what I'm going to do with my compass now is I'm just going to construct the perpendicular bisector of this diameter. So I'm going to put my compass on one endpoint, and we've done perpendicular bisectors so much now. I'm going to open up about 3/4 of the way down the line segment. The exact distance doesn't matter. Arc above and below. And then using the same distance that we just measured on the other endpoint, same arc above and below. And let me connect through my perpendicular bisector through those intersection points. And now we're all done with our construction. Oops. 1, 2, 3, 4. Those are our 4 points of the square. Let me connect them together so you can see it. And since we did the perpendicular bisector, all the sides will be equal. And the angles are all 90-degree angles. And notice how the diagonals are also congruent as well. Okay, there we go. So that's our square. Okay, the next one is a little bit trickier. So we're going to make a circumscribed circle around triangle ABC. So remember from semester 1 of geometry that there are 4 triangle centers that we learned about? We learned about the circumcenter, and that's what we're going to need for the circumscribed circle, the orthocenter, the incenter, and the centroid. Remember the circumcenter, which is the center that we need for the circumscribed circle to make a circumscribed circle. That means a circle around the outside of triangle ABC so that all the edges, all the vertices will be in the circle. We need the circumcenter, which is where the perpendicular bisectors of the sides of the triangles meet. Incenter was where the angle bisectors met. Orthocenter is where the altitudes meet. And centroid is where the medians met. So that's just a little review of the triangle centers. So all we need to do is some perpendicular bisectors of the sides of the triangle, and 3, 1 for each of the sides would make this really, really accurate. But to see an intersection point, you only need to do 2, and then you can see where they intersect. So I'm just going to do 2 for the purposes of this video. Just keep in mind, to be super accurate, you should do all 3 sides. I'm going to start with side BC. So I'm on one endpoint of the side, about 3/4 of the way down, arc above and below because I want to see both of my intersection points. Heading on over here to the other endpoint and using the same distance, I want to make the same exact arc. Let me connect through, with my line. And there I have my perpendicular bisector of side BC. I need at least one more perpendicular bisector to see where they meet. So I'm going to do side AC because I don't have a lot of markings over there yet. So let me use a different color for that. So I'm going to go over to one endpoint. So I'll go over to A first. There we go. Now my point is on A. And I want to be about 3/4 of the way down the line segment, arc above and below. Then using the same distance that I just used, I'm going to go over to the other endpoint, C, and I'm going to use the same distance I measured to make the same arc. And right through those intersection points, I'm going to connect, and that's the perpendicular bisector of side AC. So I see the point where they intersect is this point right over here. So this point right here would be the circumcenter of my triangle. And don't worry, that's not like in the center of the triangle. We have a lot of different triangle centers. They're not all like in the middle of the triangle unless we're dealing with equilateral triangles. Remember, in fact, for some triangle types, some of the triangle centers, like the orthocenter, are sometimes outside of the triangle. Same thing with circumcenter. If we have an obtuse triangle, it would actually be outside of the triangle. So it doesn't matter that it's not exactly in the center. We call this one of the triangle centers because we're actually going to use it as our center to circumscribe the triangle, and that's the next part of what we're doing. So if you take your compass and you put it on the circumcenter that we just found, and you just adjust your compass so that it opens up to just one vertex point of the triangle. The cool thing about the circumcenter, and once again, we try to be as accurate as possible, but of course on the computer, I'm not super accurate, so it might not line up exactly. But the really cool thing is if you put your compass on the circumcenter and you open up to one vertex point and you swing a circle, all of the other vertex points, so it happened here, A and C, should also be included in the circle. And now we have a circumscribed triangle where all 3 vertex points are on the circle. So that's what the circumcenter is used for, to circumscribe triangles. Okay, next we're going to make an inscribed circle in this triangle. So that means we're going to make a circle that's completely inside the triangle. And for that, we're going to actually need a different triangle center, the incenter. And if you don't remember, the incenter is where the angle bisectors of a triangle meet. And you might not remember how to make the angle bisectors of a triangle, but it's pretty simple. You just put your compass on the vertex of the angle, and it doesn't matter what distance you open up to, you just want to make an arc that's on the angle. Then I'm going to go over to one point. Doesn't matter the distance, but I'm just going to open up a little bit further. and I'm just going to make an arc. And then I'm going to go over to that other intersection point, and using the same distance, I'm going to make the same arc. And if I connect here through that intersection, I have an angle bisector. Let me bisect a different angle as well, because I need at least 2 to see the intersection. So I'm going to do A next, I guess. Doesn't really matter if I do A or C. So I just made an arc that's on the angle. Okay, I'm going to open up a little bit more, but the exact distance doesn't matter. And I'm going to make an arc. And then I'm going to go over to the other intersection point, and I'm going to make the same arc with the same distance. And starting at the vertex, through that intersection, I'm going to make my angle bisector. And I went far enough that I could see where they meet. So I see they meet right over here. So I call that the incenter. And unlike with the circumcenter, we can't just put our compass there to inscribe a circle in the triangle. We are going to put our compass there, but we also need something else. We also need a perpendicular line, and that's going to be the amount that we open the compass to. So basically, we're going to put our compass on that incenter, but we have to open up to the length of a perpendicular line in this triangle. So I actually have to do one more construction besides for my angle bisectors. Even though I found the incenter already, I actually need to make a perpendicular line to the side of the triangle. So we're going to do that. So let's make an altitude. That's a perpendicular line in the triangle. So I'm going to make the altitude to point C. So I'm just going to put my compass point on point C. And if it's an altitude through point C, it's going to intersect side AB, the opposite side from that point. So I just want to make an arc that intersects the side of the triangle AB in 2 spots. And notice my arc didn't intersect in 2 spots. So I'm just going to go ahead and just extend the side of the triangle a little bit. So that way we could see those 2 intersection points, the one here and the one here. Now what I'm going to do is I'm going to put my compass on one of those intersection points. I'm going to open up a little farther, but it doesn't matter the exact distance. And I'm going to make an arc. And using that same distance, let me just spin my compass around, else I'm not going to be able to. I'm going to go over to the other intersection point right here. And I'm going to make the same arc with the same distance. And let me get a different color so we know that this is the altitude and it's not another angle bisector. That would be the length of the altitude. So I'm just backtracking a bit because instead of making an altitude through point C, I really should have made a perpendicular line from the incenter. So I just put my compass on the incenter and I just swung an arc that intersected in 2 spots. And now that I have that, I'm going to go over to one of the intersection points just like we did before. And I'm going to make an arc. And then I'm going to go over to the other intersection point and I'm going to make the same arc. And luckily they just met. So all good. Let me get my line. And once again, we're not going to get 100% accuracy, but we try to be as accurate as possible. So once again, this was a perpendicular line through the incenter. That was the point that it was through the incenter. So now all I have to do, is take my compass. Let me get a different color, I guess black. And I hope this works out nicely because I am on the computer, so it's a lot harder to do this on the computer than it would be to do it by hand on paper. And I'm going to just open up to the length of that perpendicular line, and I'm going to use it to swing a circle. So as you can see, mine was a little bit off. Let me alter it to show you how it should look if it was 100%. So an inscribed circle should be completely inside the triangle, and it should be very, very close to touching the walls of the triangle, but it should be completely enclosed in this triangle.